Hello, everyone. In today's class, we will study two topics: the management of imported equipment and the installation, commissioning, and acceptance of process equipment. Let's begin with a brief overview of the management of imported equipment. The preliminary management of imported equipment includes planning, negotiation and inspection, ordering, acceptance, inspection and claims, warehousing, archiving, on-site management. When managing imported equipment, the following issues should be noted. First, pay attention to the economic efficiency of imported equipment. Some enterprises and their supervising departments neglect the early-stage management of imported equipment, blindly pursuing large-scale or imported machinery. As a result, the imported equipment often has a low utilization rate and poor economic performance. In some cases, due to improper model selection and the introduction of incompatible machines, the installed equipment cannot operate normally. Second, ensure proper management of spare parts. Some high-precision imported equipment cannot function properly due to a lack of essential spare parts or lubricants affecting normal operation. Third, strengthen technical support. Many enterprises have weak maintenance capabilities and cannot meet the technical requirements for servicing high-grade, precision equipment, leading to equipment malfunction or downtime. Fourth, focus on assimilating and absorbing imported technologies. Most equipment introduced by chemical enterprises is used for highly continuous production, features complex structures, and operates with a high level of automation. Now, let's focus on the installation, commissioning, and acceptance of process equipment. Equipment unpacking and inspection should follow warehouse management procedures for equipment release. The unpacking inspection should be conducted jointly by the Procurement Department, the Equipment Management Department, the Installation Department, and the Tooling and User Departments. For imported equipment, personnel from the Commodity Inspection Department should also participate. Inspection items include: first, check the box numbers, quantity, and packaging conditions. If any issues are found, record them carefully and address them promptly. Second, check and verify technical documentation such as equipment model, specifications, parts, components, tools, accessories, spare parts, and instruction manuals against the packing list. Third, check for any rust or corrosion during transportation or storage. If any rust is found, handle it promptly. Fourth, sliding surfaces that have not been cleaned should not be moved to avoid damage. Fifth, accessories, tools, and spare parts not required for installation should be properly packed and stored. After the equipment installation is completed, hand them over to the user unit together. Sixth, verify whether the equipment foundation drawing and electrical wiring diagram correspond to the actual condition of the equipment. Check whether the dimensions of the foundation bolt holes and related parts, as well as the foundation bolts and shims, meet the required specifications. Verify that the position and relevant parameters of the power connection terminals conform to the specifications in the instruction manual. Seventh, after inspection, prepare a detailed inspection record and complete the equipment unpacking and acceptance form. Equipment installation and positioning. The basic principle of equipment installation and positioning is to satisfy the requirements of production processes, maintenance, technical safety, and workflow coordination. Specific considerations include: first, meeting the needs of the product process flow and machining conditions. Second, ensuring the shortest production process, facilitating the storage and transportation of workpieces, the removal of chips, and maximizing workshop space utilization, while also making production management more convenient. Third, taking into account the dimensions of the main equipment and its auxiliary devices, as well as the limit positions of moving parts. Fourth, meeting the requirements of equipment installation, workpiece clamping, maintenance, and safe operation. Fifth, considering factors such as workshop span, height of lifting devices, and door width and height. Sixth, meeting power supply conditions and occupational safety requirements. Seventh, accounting for the geological conditions of the foundation soil. Eighth, ensuring that the floor layout is neat and orderly, aesthetically arranged, and in compliance with relevant design specifications. The purpose of equipment leveling is to maintain stability, reduce vibration, prevent deformation, avoid unreasonable wear, and ensure machining accuracy. We need to pay attention to the following points. First, select appropriate reference surfaces for leveling. Second, adjust straightness and parallelism according to the specifications in the instruction manual. Third, use shims that meet the required standards. Fourth, ensure that the foundation bolts, nuts, and washers conform to the specifications in the instruction manual and design requirements. Once leveling is completed, the equipment can proceed to trial operation. The preparations before the trial operation include the following. First, clean the equipment and apply lubricating oil. Second, perform manual rotation checks. Third, test the electrical system. Fourth, inspect safety devices. Fifth, check all operating handles. Sixth, inspect high-speed moving components. Seventh, remove any obstacles around the equipment. After the trial operation, a no-load test should be conducted. The purpose of the no-load test is to examine whether the installation accuracy and stability of the equipment are maintained, and to ensure that the transmission, control, lubrication, and hydraulic systems operate normally and respond reliably. From individual parts to components, from components to the whole machine, and from a single machine to the entire automated line. During startup, perform several jog operations first. Once everything is confirmed to be normal, start the equipment formally, and gradually increase the speed from low to high. During the no-load operation, attention should be paid to the following aspects. First, the performance of speed changes at various operating levels. Second, the temperature of bearings in all parts. Third, the noise level during equipment operation. Fourth, the stability and reliability of the system. Fifth, the coordination and correctness among different devices. Sixth, the sensitivity and reliability of all safety protection devices. Seventh, ensuring that no malfunction or shutdown occurs during continuous no-load operation. After passing the no-load trial, conduct a load test. The primary purpose of the load test is to evaluate the equipment's operating performance under specific load conditions. The load test should be carried out progressively at 25%, 50%, 75%, and 100% of the equipment's rated power. During the load test, it is necessary to check according to standards the temperature rise of the shafts, any leakage in the hydraulic system, and the proper operation of the transmission, controls, automation, and safety devices, as well as whether the operating noise is normal. After the load test, an accuracy test of the equipment should be conducted, and the following records must be properly maintained. First, records of the equipment's geometric accuracy, machining accuracy, inspection results, and other functional tests. Second, the results of the trial operation, including troubleshooting conducted during the test run. Third, issues that cannot be adjusted or resolved should be classified according to their nature, identifying whether they are due to equipment design flaws, manufacturing quality issues, installation quality problems, or technical issues arising during adjustment. That's all for today's lesson. Please complete the after-class exercises. Make sure to review thoroughly.